Here is our power board that we're going to look at. And there is our 14-way. And from that, I'm going to take, and for convenience, I have one that's ready to have a look at. Here we go. And the leftmost on the bottom row is our 8-volt, followed by our 12-volt there in the center, and ground on the right-hand side. This particular logic board is unused from new old stock. What I've done is I've taken those and hooked them up to a number of things. I should say is that any reasonable quality multimeter can be used for this process. I just happen to have two fairly good ones, and we'll go and we'll have a look at those in just a moment. First of all, we have a Rigol power supply, and one first thing I'd like to notice is I'm putting 12 volts, and you'll notice there in the amps is 0.079, so it's approximately 80 milliamps. So that is a definition of a good one, and we'll see some that aren't so good a little later. So we're going to turn our various meters on. And by spec, these you'll see that they're listed at 8 volts. So, but normally I notice that they're about 9, and likely due to that there's no load on this. So 9 volts, brand new. Now when we come to the current, on top of that DC signal, there can be some ripple or AC. In this particular case, we're about 18 millivolts. If you have a standard meter like this one, yeah, it actually stabilizes there at about around 6 millivolts AC. So that's very good. You'll notice that this one is about 3 times higher, and this particular meter is a Fluke 87, so it's really a top level multimeter. So if you get something in around this value, that's fantastic. Now we're back. What I've done is actually turned on the Rigol oscilloscope. So this is a one-shot move, and the idea here is to see those pulses of that alternating current. And if we zoom in on it, you can see there that there's just sort of spikes, and that's pretty well normal for the type of circuitry that's used here. It's called a DC to DC. And the function of our capacitors here is to filter that out so it's relatively small, as we see here. And we're back. I've now replaced the power module with one that was causing some issues. I thought initially that it may have some dirty contacts, and you'll notice here is it's labeled with that it has an error 54. So this particular one has the problem that we've noticed when we were in the car. So first of all, I'm going to go over and turn on our power supply. This one, look, we have 12 volts here, but the interesting thing is look at now nearly 0.7 of an amp. So if you remember, it was 0.07 before, so nearly 10 times the current. Something's wrong. Also, look at our 8 volts. Obviously, it should be about 9. It is not anywhere close. And look at the AC. The ripple. There's nearly 7.5 volts AC on that line, so it's not a clean signal. Let's go and see what happens here. These peaks are off the scale. Look at them. I'm still turning. Each click is twice. Amazing. All right. So we obviously have a problem. Okay. So number one, I would because the HEPs are running on 8 volts, which is our line over here, and it's not, and it's 12, and there's a lot of AC, that's my suspicions, is that it is our capacitors here are causing a problem. So let's have a look at capacitors. And we're back. You may have noticed that this is a different power board. I had two that have exactly the same issues, so just for convenience for the video, I have replaced those two capacitors. Don't recommend getting cheap ones here. Recommend getting top-notch ones like made in Japan, such as Rubicon and Chemicon and such high quality stuff. They're relatively inexpensive. Once again, we'll look at the voltages, and here we go. Now it's just about 9 volts, which is great. We have now the number of millivolts is of the AC is 12. And let's have a look at the power supply. So look at that, approximately the same as a new one. Fantastic. So we'll go right back and let's see what our friend the oscilloscope says. Oh, look at that. The peaks are now at a reasonable size, very similar to the brand new board. And now we're back looking at capacitors. So here is the original capacitor. They are 220 microfarads. And then I have one here, which is a modern replacement. You notice it's a little smaller, but of course, if you'd rather, you can get larger ones, just like that. Now, these are a little bit more difficult to test. All the previous things that you could do with just a single multimeter and your 12-volt battery from your car. So pretty easy to diagnose. Next, what I'm going to do is I'm going to show you that the capacitor is bad. And what I'm going to do is use what's called an LCR meter. And these are designed very specifically to test inductance, capacitance, and resistor with high accuracy. So I'm just going to change the frequency here. Let's not worry about that. And on the screen there, the top value is a quality 0.032, which is great. And these are 220 microfarad capacitors. Usually they're plus or minus 20%. So you'll see there is we have 193 UF. Okay. So now we put in the old capacitor in. And if you look at the value, notice the quality value is 1.13, so it's nowhere close. Orders of magnitude. The next thing is you'll see a value of 1,000 there, but if you look to the right-hand side, it's NF. So the units is nanofarads, which is 1,000 times smaller. So therefore, if we move that decimal to the left 3 times, it's 1.1 microfarad. So we've lost 99.5% of the capacitance of that cap. And there's our freshly modified. You can see the shine coming off the top of the caps. So it's in the car, ready for testing. So I have my fingers crossed. Let's see how we did. Ready, set, go. Tach looks pretty stable to me. And the engine's cold. I would take that as a win. Thank you for watching.